See the question. Exercise 10.2. If a tangent BA and PB from a point P and Q from point P to a circle with center O are inclined to each other at an angle 80 degree. So it is PA and PB. Look here. PA and PB. If a tangent P and PB from a point P to a circle with center O are inclined to each other at an angle 80 degree, then POA is equal to POA. See, how can you find out POA? It is not simple. You have to think a little bit. Even though MCQ, you have to think. Listen here. Here, it is 80. We have to find out POA. POA, see, dotted line. POA means this line. How can we find out? Think about that. How can we find out PA? Can you find out? A or B, can you find out? A or B? Yes, A or B you can find out. How? Because this is 90 degree tangent and radius perpendicular. So we can find out angle A 90 plus 80 plus. This is suppose AOB, angle AOB X. I am putting this is X. Or keep it angle AOB. That is equal to 360. Because AOBP is a quadrilateral. In a quadrilateral, what is the total angle? Total angle is 360. So we got BOA or AOB. That means 360 minus 90, 90, 80, 80. That means 260. So angle AOB is equal to 360 minus 260. What are degree? That means exactly 100 degree. AOB is 100 degree. But the question is, find AOP. How then? Central angle we got now. This angle of inclination, 80 degree. Angle of inclination is 80 degree. Central angle AOB we got now. Now we have to find out this small angle. That means I am marking this. Listen here. AOP. We found AOB, we found blue color. And we got 100 degree. Now how can we find out AOP? For this, you have to take two triangles, AOP and DOP. Okay? From triangle AOP and BOP. Okay, write that. From AOP, from triangle AOP and triangle BOP. Triangle BOP. AOP and BOP. Okay, two triangles are there. AO is equal to BO. Can I say is a right triangle? Yes, of course, because perpendicular. So from right triangle we can write from right triangle AOP. That is better. Then congruency of RHS congruency you can apply. From the right triangle AOP and right triangle BOP, AO is equal to BO. Radius are equal, radius of the same circle. Okay. Now one more thing. Okay, is the OP is equal to OP. That is common. OP is equal to OP because it is common. Now we can say two triangles are congruent. Two right triangle hypotenuse and one side are respectively equal to the hypotenuse and one side of another triangle. That is why now we can write right triangle AOP congruent to triangle BOP. AOP congruent to triangle BOP. Okay. Now, after that, AOP congruent to BOP. So what have to prove? In two triangles, these angles are equal. That means CPC. Can I write the angle AOP? Not triangle, angle AOP. That is this angle equal to angle BOP. Now triangle, I'm talking about angle now. Angle AOP, that is equal to angle BOP. Because CPCT corresponding parts of congruent triangles are equal. Before that we got, this is the blue color, angle is 100 degree. Now what happened here? AOP is equal to BOP. So AOP is equal to BOP. I can write that angle AOP plus angle BOP. AOP plus angle BOP. AOP plus angle BOP. That is equal to 100 degree because that is AOP. That is 100 degree. Before that we wrote this one. This is 100 degree. We got first we got it is 100 degree. We got it. This is 100 degree. Now here maybe this equation 1. AOP is equal to BOP. We need AOP. The question is find the angle AOP. So AOP plus BOP I can write AOP plus AOP. AOP plus AOP that is equal to 100 degree. So AOP plus AOP is 2 times AOP that is equal to 100 degree. That means angle AOP is equal to 100 by 2. That means 50 degree. You got the answer. That is it. Even the multiple choice, see the working AOB. Okay. So what is the question? POA. Okay, POA we got. That is it. 100 by 2, 50 degree. This is 50. I think you understood. 50 degree. Okay. Now, next question. What is the next question? Prove that tangent drawn to the ends at the ends of a diameter of a circle are parallel. Tangents drawn at the ends of a diameter are parallel. Look the fourth question and draw the figure. Look the fourth question and draw the figure. Now, listen here. Fourth question is very easy, but we had to draw the figure. Figure is not given that. Prove that tangent drawn at the ends of a diameter of a circle are parallel. Again, see the circle, diameter. This is the diameter. You know diameter. Then tangent drawn at the ends of a diameter of a circle are parallel. Circle is here, diameter I drew, then tangents. One tangent you can draw like this, another tangent you can draw like this, okay? Hence of the diameter. So they are parallel we had to prove. We can give name, two name we can give. Suppose this is A, this is B, ends of the diameter. So this is a line, this is also a line, tangent is a line which is touching the circle in one point. We studied before that two parallel tangents are there. Here also, here at least one pair parallel, one pair. How can we prove that? Here these two tangents, okay. This is the point of intersection. Here the A and here B. We have to prove this line L, line M, that means two tangents. L and M are parallel. How can we prove? Okay. Now, suppose we can see one angle here. Here one angle. Then it is 90 degree. It is 90 degree. Because this is the center. Line segment joining the radius and tangents are perpendicular. Tangent is perpendicular to the radius. Okay. So it is 90 degree, 90 degree. Now, for convenience, I am giving line L instead of here I am giving A, B, C, D. No need L. Instead of M, A, B, C, D, this is E and this is F. That is good. We have to prove CD parallel to F. Okay. Now look the figure. If it is 90, this will be 90 degree because straight angle. If it is 90, again this will be 90 degree. Sorry. Because it is straight angle. Now it is simple. You can say angle CAO, angle or OAC, that is equal to 90 degree. Do you agree? It is 90 degree, of course, 90 degree. And angle ABF, angle ABF, that is equal to 90 degree. Correct? No? It is 90 degree, it is 90 degree. So AB is the transversal. Look here, two lines We don't know the parallel line, something like that. But one thing, it is very clear. It is 90 degree. It is 90 degree. Or another line, see, parallel line. 90 alternate angles are equal. Correct or not? Suppose this is x. This is x. Alternate angles are equal. So here no need, we know this one here, it is given. See, 90 and 90. So from here, we can say two lines are parallel. Okay. We can write here CD lines CD parallel to line CD parallel to line EF. Why? Alternate angles are equal. Alternate angles are equal. Because alternate angles are equal. If alternate angles are equal, lines are parallel. You proved it. That is over. I think you understood. If you are not coming to alternate angles, we can say here co-interior angles 90 plus 90, 180 degree. Co-interior angles are supplementary. We studied if a transverse intersect two parallel lines, co-interior angles are add up to 180 degree. Alternate angles are equal. Corresponding angles are equal. Then after that, if corresponding angles are equal, two lines are parallel. If alternate angles are equal, when two lines are there, okay, one more line I need. Okay, red color is here. Two lines. This is a transversal. But alternate angles are equal. Then the two markers are parallel. Red marker, then blue marker, and here it is dark black marker. Now it is not parallel. But according to the theorem, if this is a transversal, if a transversal intersecting two lines, alternate angles are equal, then the two lines are parallel, two markers are parallel. First we studied if two lines are parallel, three conditions. Alternate angles are equal, corresponding angles are equal, co-interior angles add up to 180 degree. Now converse. Here, two lines are there. We had to prove two tangent. These are two tangent. They are parallel. We had to prove. You can see it is the diameter. This is the diameter now. Okay, sir. Yes, understood. It is the diameter. The red pen is the red marker is the diameter. Imagine the circle is the diameter. So it is 90 and 90. Because right angle, four angles are the equal. 90, 90. So anything we can say. Alternate angles are equal, this angle and this angle. So it is parallel. Or core interior angles, 90 plus 90, 180 degree. Don't confuse. You take alternate angles are equal here. Alternate angles are equal. So the two tangents are parallel. I think you understood. Now we can check the next question. Now listen here. Next question. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Perpendicular that the perpendicular at the point of contact to the tangent to a circle passes through the center. Okay. Perpendicular is the no circle is there again. Draw the circle. Is the circle? It is the tangent. And we have to prove, suppose this is the center. Perpendicular passes through the center, we have to prove. Okay. So this is the perpendicular. We have to prove it is passing through the center. This is the tangent. Now listen here. Suppose it is not passing through the center. Circle is there, then there is a tangent on the point P. Now it is not passing through the center. Suppose perpendicular here in the question, perpendicular at the point of contact to tangent to a circle passes through the center. Why the center of the circle? AB is the tangent at P. You can see that. We have to prove that the perpendicular P to AB passes through A. Let the perpendicular at P point AB does not pass through the A. Suppose it is not passing through the A. It passes through O dash. Okay, fine, good. Interesting. So it is not passing perpendicularly passing through another point. O dash. So join it. Suppose, see, we have to prove through A through the center. This O dash, if it is not passing through O, let it pass through the perpendicular pass through O dash. So we can say PV O dash 90 degree. If it is a perpendicular, it must be 90 degree. Understand? Now look the figure. You are telling here P OPQ, suppose OPQ. PQ is the tangent. Look the figure now. O dash PQ. You are telling it is perpendicular, it is 90 degree. But in the figure, it is very interesting, quite interesting, I can say. O dash PQ. Angle O dash PQ is equal to 90 degree. Can you see there? O dash PQ less than OPQ on the figure. Am I right? Angle O dash PQ. See, I am marking this one. The black color OPQ. Then the blue color already marked here. The blue color that is O dash PQ. But according to this, what is here? O dash PQ 90 degree. But it is very clear O dash PQ less than OPQ. Look the figure. We know that the radius is perpendicular to the tangent. Radius is perpendicular to the tangent. Therefore, OPB 90 degree. Now, comparing this, what you are getting? Very interesting. This also 90 degree. See, this angle. Here we are getting the angle. Here, the angle here. This perpendicular. See, look here. This angle we made exactly from here. That is 90 degree. Because tangent is perpendicular to the radius. OP is the radius of the circle. So, but we can say, but angle OPB is equal to 90 degree. Do you agree? OPQ, sorry, not OPB, OPQ. This OPQ 90 degree because tangent is perpendicular to the radius. Tangent is perpendicular to the radius. Tangent is perpendicular to the radius. That is why we know OPB that is equal to 90 degree. So what happened? Here, O dash PQ 90 degree first. Here, this is 90 degree. What we are assuming here, it is not passing through the center. It is passing through the O dash. We know line segment from the center. Okay. This is 90 degree. That will be 90 degree. Now, from 1 and 2, what happened? Angle OPQ, that is equal to angle O dash PQ from 1 and 2. From 1 and 2. How it possible? OPQ is equal to O dash PQ, but O dash PQ less than OPQ. So contradiction. It is not possible. What we wrote there? From figure it is clear that O dash PQ less than OPQ. So it is not possible. Not possible. It is possible only when OP and O dash P coincident line. Therefore, the perpendicular drawn at P passes through the center O. Listen again. O be the center of circle, tangent, P is the tangent. We had to prove the perpendicular at P to AB passes through A. Passes through A. Oh, sorry, not A. Perpendicular at P passes through O, we have to prove. So let the perpendicular from P does not passes through O. It passes through O dash. Join OP and O dash P. Tangent drawn P passes through O dash. See, really interesting. It is not passing. Let it pass through O dash. So O dash PQ is equal to 90 degree. O dash PV is equal to 90 degree. We got tangent P passes through O dash. So it will be 90 degree. After that, tangent and radius is the radius. OP is the radius. That is 90 degree. So 1 and 2, OPQ is equal to O dash PQ. But from the figure, what we are getting? From the figure, look the figure. O dash PQ less than OPQ. That is why O dash and O are coincident. Okay, I think you understood. Comparing 1 and 2, we got O dash PP is equal to OPB. It is clear that O dash PB less than OPB. Therefore, O dash PP is equal to OP PB is not possible. It is possible only when OP and O dash P coincident line. Therefore, the perpendicular drawn at P passes through the center O. In this case, it is not possible. It is possible only O and O dash coincident. Okay? So like that you had to write from 1 and 2, OPQ is equal to O dash PQ. It is not possible because from figure, O dash PQ less than OPQ. Are you following or no? Suppose I am giving this 3. From 3, from equation 3, look the 3. O dash PQ less than OPQ. Not possible. Only proceed from 3. It is not possible. Not possible. Because it is less than. Only possible. It is possible only. Only it is possible if O and O dash, if O and O dash, if O and O dash, or OP and O dash P. O and O dash means OP and O dash P are coincident lines. O and O dash are same means we can say OP and O dash P are coincident line. Coincident lines. Therefore, the perpendicular drawn P passes through the center, or like the last statement you have to write. See, something you have to talk only, you can show like this one. Okay. Okay then.